Hey everyone, this is FixReef and today we have a brand new repair. These two units came in from the same customer with essentially same problems, or at least on the surface they're the same. These are the Kessils, I should say the dreaded Kessil A360X, both of them. So I figured that this will be a really good repair video after so many repairs that I've done on the slides to kind of start highlighting issues in general with these units. Those of you who have followed my videos, repair videos in the past already know that I've repaired some of them, at least on the camera, and I've already mentioned some problems, but today we're going to take another look at some of these problems and kind of see what we can do about them. I have not opened up the slides yet. I have no idea where the problem is or how many problems there are in there. So together we will find out what's going on here. I feel fairly optimistic that it's going to be a successful repair, so let's just start diving in. I'm going to put this slide aside for a moment and we will start focusing on this one first. So the disassembly is fairly straightforward. Again, we're removing knobs carefully without breaking anything, without damaging anything, so that we can put it back all together. Then we can do one of the two things. We can suppose remove this little nuts over here. Along with washers underneath. I have seen, I think recently there was a light that came in that somebody tried to open up before me, and for whatever reason they decided to put the washers on top of the nuts. I'm not sure what was holding them other than the knobs. Anyway, and then we need to remove these two metal ones. You can't even imagine how many units I've received where somebody already tried taking them apart and broke this metal bolts over here. They're stainless steel, I guess, bolts of some kind. They are very, very delicate, and they often seize inside the unit after years of being exposed to salt, and there isn't an easy way to remove them. And those who try to put too much force into trying to remove them, they break them. It snaps right here where it's the thinnest. It just snaps right off, and then you cannot really replace it because half of it is stuck inside of the thread inside of the unit. So let's try to avoid that. And my advice to those of you who are trying to take them apart at home, do not put any force. If you just cannot use what I just did with a screwdriver, just gently, they don't come out, do not put additional force. Otherwise they will guaranteed snap. Anyway, so there are two bolts underneath. These ones can also be tough, but they are made of stronger metal. So these ones we can actually try to force out. Alright, so now that the light is completely disassembled, let's open it up. Looks like this has been exposed to quite a bit of salt. The USB ports are corroded, slightly, not a whole lot, but slightly, and otherwise quite a bit dirty. Alright, so let's now apply some voltage, see where that gets us. So these lights take 19 volts. Those of you who are looking for replacement power supplies, consider good old laptop power supplies that have amperage comparable to the originals. They work just fine on these lights as replacements. Okay, so plugged in, let's give it some power. And my power supply, my lab power supply or benchtop power supply shows absolutely no current being consumed, which indicates only one thing, and one thing only. There is an immediate failure on the input power circuit. This is probably the most common issue with these lights. So what I'm going to do is I'm going to have my multimeter on, and we're going to attempt to diagnose the issue here. So what I'm doing is temporarily I'm going to connect the ground rather, to my other output of the power supply, so I have common ground. And now that I have common ground, I can test. All right, let's see what we get. So everything's plugged in. We have no power. We're going to test power at the output of the MOSFET, the output of the power circuit. It kind of shows less than one volt, and I doubt that we are gonna get any more. So even on this side of the resistor, not to mention the other side. So that's okay. That means that something else is not functioning. Now, if you remember from my old videos, this is where the power circuit is. Let me see if I can clean this up a little bit, because it really is kind of filthy. Okay, so if you remember, the power comes in at right over here, at this point over here. This is where our power cable comes in, and then it goes through this power circuit over here. So if we were to attempt to measure voltages on the input, we better see 19 volts, or give or take, yeah, about 18 and a half, about 19 volts coming in. We know that everything is fairly good. Now the rest is the typical problem with all of the Kessils. Very, very low quality resistors. Before working on these Kessils, I didn't even know that resistor is a common failure. Capacitors fail in power circuits, transistors fail, MOSFETs fail, controllers for that matter fail, but I've never realized that it's possible to have so many resistor failures. Alright, 6.2 volts, that's already wrong on this one, and nothing here at all. Power comes in, and it doesn't even bother coming out. Unbelievable. So we basically have 4 resistors here. 4 on the. These are probably the only 4 resistors on this power circuit, and all 4 of them are in some. All right, so we're finally all set up to replace these resistors. You can kind of see 2 of them. You can see fairly well. 2 of them are hiding over on this side under the or next to diodes. So we'll get to those in a minute. Let's start by removing one of these guys. So I'm going to go ahead and start removing the offending resistor that's guaranteed to have issues, and we'll see if the other one needs to be removed as well. What I found useful is that because this is so covered in silicon, it's actually easier to remove it with a hot iron than it is deal with knives and stuff. So let's just, hot iron just cuts through the silicon easier and removes some of this nonsense. That's good enough. Now we can pick it up and haul it away. You have to be real careful here, because you really want to melt the solder before you pull, because if you don't, you're gonna break the there you go, you're gonna break the pads, and that's just not a good thing. Okay, one resistor is gone. All right, and I'm gonna go ahead and remove the other, more than likely offending resistor, which is in really tough spot over here between a very large shunt resistor and a very large diode, and covered in ½ an inch of silicon. And of course you can't see any of it too, because I'm looking inside the microscope. and my field of view is wider than the field of view of the microscope camera. But that's the other resistor. We should be able to get rid of that too now. I've been ordering these resistors by hundreds. I don't even bother with like 20 or so, 25 resistors, because of the volume of the slides coming in. They all need this stuff. And so you can imagine how many of them I have to remove in like a given week. But it also goes to show the issues, the massive issues that Kessil has with the slides. All right. Okay, now that both, I will clean this up. There are some dead resistors laying around there, right? So let's actually clean this up now, because it just makes it for a nicer work area. Alrighty, so all we need to do now for both of them is we need to put some fresh leaded solder on. Leaded solder is going to stick to the pads, and it's going to have a lower melting temperature, which will help attaching these resistors back on. Alright, we'll start with the top one. That looks pretty good to me. Not sure if you can see it, but there's some nice balls of solder. And let's do the lower one next. That's more than enough. All right. Okay, now we're kind of ready to put new resistors on. So again, I'm going to start with the top one. And I'm going to put the one on the bottom as well at the same time, so I have to go back and forth. The resistors are at least placed, but not replaced. There's one here, and there is one at the bottom. I only use high quality resistors. I go for mostly Japanese brands, Panasonic, and such that I know are gonna work. I can only imagine what type of resistors Kessil decided to, or what quality of resistors Kessil decided to put on the slides. I can only imagine. With the failure rate, I suspect what they're seeing is the failure rate of close to 100% on this. Outside of the warranty window, of course, but it has to be extreme. It just has to be extreme. Okay, I think both of the resistors are in place now, and they look quite good, just need to be cleaned up. It kind of looks crooked, doesn't it? It's probably okay, but it's looking crooked, and I don't like things when they look crooked. Let's get it properly positioned, because I need to be confident in the connection between them. I need to be confident that everything is conducting as it should. All right, that's much more straight. Okay, unfortunately some things are a little bit out of focus for you, but this one is now much straighter. Okay, let's get from under the microscope and see if this light works. So what we've done so far is we've replaced 2 resistors on this light, and there is absolutely no guarantee that these are the last resistors we're going to be replacing. So let's find out. Power on. Oh. Well, at least we get the power, the fan, but the fan is spinning like crazy. The fan is out of control, and the light is still not working. But it responds, you can see that it responds to the intensity knob. It turns on the fan, but it turns it on very, very, very loud, and then it's off. So what this tells me is that there are more issues. So this is turning into an exciting repair. So what other issues are we going to expect? We are going to expect more problems, and then more problems with resistors here. There is nothing on this light that fails more often than resistors do. So we're about to find out what else is broken. All right, so we know that the power gets to the controller and the power gets to the fan. The problem with the fan is that it's super, super loud. Many of you complain about how, I read it on forums a lot, how loud the Kessil fan is, or can be. There is actually a solution to this problem. If your fan is loud, or maybe it wasn't loud before and now it is, there is an issue. And I will explain in a moment, but I'm going to test a few more things before I jump into this. Essentially, when you test resistors on these lights, what you want to see is low values. If you start seeing values in 300 kilo ohm or more, 2 to 300 kilo ohm, it's a sign of trouble. So we're going to test a few resistors around here and see if they show anything. Like for example this one. I don't know if you can see this, but this resistor over here, not too far from the controller, is showing 33 mega ohms. A 33 mega ohm resistor. So we are going to fix that. We are going to fix this. So that's a failed resistor, another failed resistor. We're going to test a few more. I already by now mostly remember what the values are supposed to be here. And if I see something weird, I know there is a problem. Looks like this resistor showing 27 kilo ohm is also bad. 370 kilo ohm. This resistor is bad, so that's 3 resistors to be replaced. So these just 3 resistors around the main controller circuit. Just 3 resistors around the main controller circuit, in addition to 2 resistors we just replaced on the power circuit. And we haven't even gotten to the LED channels yet, which are these 2 main controllers, or these 2 LED controllers over here, and we haven't gotten to the fan yet. Let's get to the fan. All right. The fan circuit is somewhere. Now let me remember what the fan circuit is. The fan circuit is in this corner over here, not too far from USB ports. So let's take a quick look at some of the resistors around this. I know you guys can't see where I'm pointing because there isn't a whole lot of light in there, unfortunately. We'll get to that under the microscope soon enough. So far, another 26 mega ohms, and this is on the fan circuit. 25 mega, well, 20 some mega ohms. So far I've identified 4 additional resistors that need to be replaced on this light, in addition to the 2 resistors we just replaced. So we are going to replace more. So let's jump under the microscope. You will see it a whole lot better, and we'll try to fix this. Just because I can, I'm going to start by fixing the fan circuit resistor, because that way you can immediately see how different it is once it's replaced, how quiet it's going to be once it's on, how quiet it can be, how quiet it should be. Okay, so we are right around our fan circuit here. So we are going to go ahead and attempt to replace a resistor. These resistors are going to be tiny, super tiny, so we are going to have to use the caution and definitely the microscope to remove them. So let's grab this guy over here. That's the resistor that was showing, I think, at least 20 mega ohm resistance on it. And if this is the only resistor on this circuit that's bad, then hopefully we will see a much quieter fan after we do this. And so when you guys send me these slides for repair, I do it methodically, checking every single failure point that I'm aware of, which at this point I think I know everything there is to know about these Kessil lights because of just the number of them that I have had to repair. And I just go through them like this, and I find even if they're not manifesting themselves yet in some shape or form, I just find whatever is out of ordinary, if something that is clearly not what it should be, and just go ahead and replace it. Because I know that if I don't, it's if it's not failing now, it will fail in the near future. And we are trying to make sure that the reefing gear that we have in our possession or in over our tanks actually works and sort of works reliably. I think many of you have to deal with business trips, being out of town. We just had holidays where people would go out of town for a week or at least a few days or a weekend, and need to be confident that your equipment works, and it just is not the right thing when it doesn't. Alright, so let's get a resistor to replace this. These are the not probably, but definitely the smallest resistors I have to deal with. These are the 0402 size, which means that they're full 4 millimeters long and they're only 2 millimeters wide. This is the type of thing that I cannot solder without a microscope. Just can't. Okay, so this resistor is in place. I'm gonna hold off on cleaning everything because I have a few more resistors to replace here. I will clean everything up once I'm done. But for now, I just want to see if I can plug this in and the fan is gonna stop spinning like crazy, and instead will just hopefully come on and quietly work. Let's give it a try. So we have this on. No, we actually don't have it on. Let me give it powered up. The power is on. Let's see. Oh, look, the fan is on, but it's no longer a helicopter sound. It's nice and quiet, just humming along. So that was that. But obviously, the light has no other sign of life. There is nothing going on. But at least the fan is doing well. Well, that's okay. We still have at least 3 other resistors to replace. Back under the microscope and get them done. Well, I suppose we can always start with this resistor that was showing also something like 30 mega ohm resistance. So let's get this guy out. This is also the 0402 resistor size. So this is going to be also a fun one to try to get out. But it worked. Okay. The area is prepped. Now let's put the resistor on it. Alright, let's move it in place. And secure it. Looks perfect. Alright, that's just one. We've got a couple more. So let's get this guy out of here as well. I think this was causing issues too. And for that matter, this one, both of them weren't showing the correct values. So you guys tell me, why do you think so many resistors fail on these lights in various spots? So far, just on this one light, 3 different circuits, different resistors of various different values, or various resistors of various values fail. In some cases, I can see how a resistor fails on a power circuit when high voltage, or higher voltage I should say, goes into it and it's stressed. Maybe, sort of, maybe. But I do not understand in what universe a good resistor would fail around low voltage main controller. It should just never ever happen, ever. Yet, in Kessels, this is the most common occurrence. Nothing else at all compares to the failures of this type. I've replaced controllers that sometimes fail. I replace capacitors and diodes that sometimes fail. But resistors on here fail all the time. I honestly do not understand this at all. The only logical explanation I have for as to why resistors fail on Kessels is because they are of a very, very, very poor quality. Kessil likely got a batch, or multiple batches I should say, of resistors from China and felt that it would be a good idea to just go ahead and use these resistors in their expensive product. So eventually, of course, as anything that is low quality, cheap, it fails. There's no way around it. And we are paying the price. First, we pay a price to acquire these lights, a premium price, and then we pay a price to either repair or replace them. I do not understand. Maybe I'm getting old, but I don't understand the idea in the culture where we just pay for an expensive product, it fails, we throw it out, we go and buy another one, and it fails again, and we throw it out again. And we keep doing this again and again and again. I don't get it. It's part of the reason I started doing this, to help the reefing community, because I just don't see a good reason to keep throwing out equipment that costs good money. You know, when you buy something from China that is cheap and it fails, you kind of expect it fails, and therefore well, it's cheap and therefore it fails, you go and get a new one. But it was dirt cheap anyway, so why not? But when you pay $400, $500, $1,000 for a reefing light and potentially buy multiple of those reefing lights, and they fail on you right outside the warranty period, something's wrong with that picture. Anyway, let's let me focus a little bit more on this. But let's have the other two resistors replaced and see if that's going to fix the light. I'm still not entirely confident that everything is fixed, but we will find out in a minute. Alright, both of the resistors are in. Let's jump back to the top view camera and see if this light's fixed. Okay, so far we've replaced, I don't know what, 7 resistors no, six resistors of various values in 3 different circuits. We've so far achieved a couple of points. We've gotten the power to start flowing into the main board. We've gotten the fan to quiet down and work as it should. Now let's see if we will get the LEDs to turn on. Here comes nothing. And here comes nothing. Still nothing. So the fan is working, right? Obviously the power is on for the unit, but it's still not running. That means that we've got more resistors to replace. That's all what it means. We are not done. Okay, so now that we have the power circuit resistors and the main controller resistors mostly checked, although I do need to check a couple more of them. Wait. This is the only resistor I know here that actually is correct value going over 200 kilo ohm. So we're going to leave that alone. This doesn't look right. I'll have to go to my schematics and verify because 170 is also kind of high. 300 kilo ohm, 317 kilo ohm. That's the resistor on a white channel, I think, circuit. So that's bad. That resistor is questionable. But still nothing on the blue channel, which kind of surprises me. I would imagine that there would be something on the blue channel as well. But nothing. We will not, actually, let's go check the other side of this board because there is more, a whole lot more on that side, which is relevant to specifically the blue channel. And something tells me that we're going to have issues here as well. $400 kilo ohm. 400 kilo ohm. That's resistor number 8 for replacement. Mega ohms, 4 to 5 mega ohms, that's resistor number 9, and this also showing 138 kilo ohm, which is wrong, so that's resistor number 10 for replacement. That explains why the blue channel is not working. Okay, all right, so we have about 4 more resistors that need to be replaced. Back under the microscope. All right, it looks like, so this is the white channel, and it looks like that resistor that I was suspecting is actually okay, but this resistor definitely needs to be replaced. So we're replacing so far 3 resistors. So let's get that guy replaced. Okay, so let's yank it out first. I apologize if it's going to go out of focus for you, but I'll do my best. It's the only, I think, resistor on this side, so I'm just gonna go ahead and put a new one in. This one is a little bit larger. It's a 0603 size, which is again 6 millimeters by about 3 millimeters. So that goes in pretty easily. So that's the white channel. We're going to flip it over and deal with the blue channel. So, all right. So on this side, we are going to focus on the resistors here. I mentioned previously that I wanted to replace 2 of them because I think some of them were showing something like a few mega ohms. But I now want to test all of them just to see what they show. I'm sure you can barely see this, and you cannot see my multimeter, but this is showing 15 mega ohms. This is showing 138 kilo ohms. This is showing 400 kilo ohms. And this is showing the correct value. So of the 4 resistors in that bank, 3 of them will have to be removed. 3 all together. So that brings us back to about 10 resistors that will have to be swapped here. And these are circuit number 4 and circuit number 5, if not circuit number 6 at this point. Okay. Hopefully you can see that I've removed the silicon off of them. And now we're going to attempt to remove 3 more resistors here. Gone. 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 Alright. With the 3 resistors completely removed, we are going to have to put some solder on there. So a little bit of flux and nice solder joints. Some of you guys call them solder balls. I'm just trying to be nice and call them solder joints. These joints require a very good soldering iron because the board that they're on absorbs heat very good. The one thing that Kessil did right is they made a good thick main board that absorbs all of the heat, or a lot of heat rather, but it also makes it more difficult to work. Okay, so all joints are nice and in place. Now we need to get 3 resistors here. I was hoping to show you guys repair for 2 Kessils today, but I don't think I'm going to be able to get to the second one. Run out of resistors. But this makes for a very, very good repair video because it just shows a perfect example of what I've been dealing with for a couple of years now with these lights. Not every light rather comes in with so many problems, but every light comes in with a subset of these problems, a variation or on the problem. Every single light has this type of issue. Even if the main problem is, say, the main controller is damaged or the LED controller is damaged, it does not matter. I go through the resistors and I find out that in addition to everything else, there is also a resistor problem. Always. These are the tiniest 4.2 resistors. So I don't know how much you can see, but these are very, very tough to put in. I used to do it with hot air, and I found it even harder because, again, the board absorbs a lot of heat. Soldering irons are better. Okay. All right. Once again, I am not cleaning anything because I have no idea if how many more resistors I'm going to have to swap. So let's switch back to the main camera. Check the light. Okay. So with 10 resistors replaced so far on this light in 5 to 6 different circuits, let's see if now we will get some type of LED light coming out. Hey, looks like we have a winner now. I have my bench power supply set to very low amperage just in case there is a short. Looks like there is no short, so I'm going to give it full power and turn it on. And look at this. We finally have a winner. So let's see. I don't know how much you can see, but it definitely changes the color from blue to white and back. And we have the intensity controls in place as well. I turn it off, the fan turns off, I turn it on, the fan turns on. Everything seems to be working. Let's assemble this light. I'm going to clean it first, of course, with all of the flux and stuff. So, what do you guys think? Leave some comments. Let me know what you think of all of this. When I started working on Kessils, I just could not believe the amount of issues these lights have. Everyone raves about these lights. They're nice lights. They look nice. They are very powerful. They're compact. They're really good for tanks with like smaller tanks. As far as the output goes, light output goes, and the intensity and everything, but I don't know what Kessil's been thinking about this. I cannot imagine. Anyway, let's assemble and do the final. Let's assemble and do the final test. I have learned a lot of things with the slides too, because again, until encounters with Kessils, I did not expect that in electronics you're going to have so many resistor failures. Anything but resistors. Resistors, you talk to guys, you listen to guys online, you talk to guys who are in that type of business, and they'll tell you that resistors never fail. You kidding me? Resistor now. And in fact, it is. So I ended up creating my own schematics for this entire light because I basically need to know value of every single resistor in every single circuit, because what if something fails and I need to replace it? The light is now finally fully assembled. Let's plug it in. And it looks like it's working. I can control the intensity and the color. The fan works. All is good. Well, what did we learn today? In this particular light, I had to replace, let me take a look here. In this particular light, I had to replace 10 resistors in 6 different circuits. In the power circuit, in the fan circuit, in the controller circuit, in the blue and the UV channel circuits, and in the white channel circuit. 10 different resistors of different values in 6 different circuits. And this shows a perfect example of Kessil's failing miserably. I don't think I can easily convey how incredible the issue of the 360Xs are for Kessil. I cannot imagine their failure rate because I've been very, very successful at fixing these lights. And I've been doing this for years, and every given week it's dozens of lights coming in. They're repairable, they will work, but out of the box, original quality is incredibly low. Well, this completes this repair. This was Fix Reef. Thank you for watching. I'll see you next time.